Seebeck effect, dream for thermoelectric devices, third power generation. Possibility of composite Super SWCNT/CNF. When there is a temperature difference between the two ends of an object, electricity is generated there. An electromotive voltage is generated. This is called the Seebeck effect. Z in ZT is the performance index of thermoelectric conversion. T is the absolute temperature. The higher the value of the product of the two, the better the thermoelectric conversion. S is the Seebeck coefficient, sigma is the electrical conductivity, S/m, lambda is the thermal conductivity. And T is the temperature. Since T is temperature, it is an external condition, so it is excluded. What we want to know is the Seebeck coefficient, but since we do not know it, we also exclude it. Then, the ideal thermoelectric material, composite material, is a combination of high conductivity and low thermal conductivity. SWCNTs have high conductivity and CNFs have low thermal conductivity. If the two are uniformly mixed, an ideal thermoelectric element material with high strength can be produced. See the properties of composite Super SWCNT/CNF. Reparate 3 sheets. Number 1 Super SWCNT/CNF. Number 2 Super SWCNT/CMC. Number 3 MWCNT/CMC. The concentration is the same, and the thickness of the sheet is almost the same. Surrounding temperature 27.5 degrees Celsius. Temperature of heated stainless steel object 153 degrees Celsius. Place an object on each sheet and measure the voltage between the object and the sheet. The higher the voltage, the better the thermoelectric element. Nearly 20 years have passed since the development of CNT applications began. But they have not been used successfully. This is because they do not disperse well. Because it cannot be dispersed, the only way was to crush it. It is impossible for this to work. This is because the impurities contained in CNTs cannot be removed. It is amorphous carbon agglomerates of non-crystalline amorphous carbon that encapsulate catalysts. We call it dark matter. Its size and solidity are uneven and vary from production lot to production lot. It is also carbon, so it is not counted among the purities. Even if we know the amount of metal catalyst in a 95% pure CNT, no one knows how much dark matter is in the blend. The DMR system and the barrier module solved that problem. So it mixes with CNF and it mixes with melted thermoplastics. Electromagnetic shielding, anti-static and strength enhancement to thermoplastics, concrete reinforcement, etc. are now possible. Since metal catalysts are indispensable for CNT production, impurities are trapped in the catalyst. And even if the CNTs are defibrillated and dispersed, the impurities can easily become a nucleus and cause agglomeration. The DMR system can remove impurities with DMR while at the same time eliminating bundles without damaging the CNTs under optimal dispersion conditions. No other company can imitate this. The DMR system can eliminate the bundles of CNTs in their original form. So it is possible to bring out the full potential of the CNTs. The cohesive nucleus is removed, and from the strong bundle bond, the CNTs are unbroken and unraveled. This sheet was used for thermoelectric element data. You can see that it also has strength and electromagnetic shielding functions. CNF is the cellulose, the tree, that surrounds the CNT trunk, and if the CNF is firmly attached to the CNT, it becomes the most powerful tool.